Okay, just like we were multiplying and adding and subtracting with polynomials, we can also divide with polynomials. So we're going to go over that real quick. So the objective, students will be able to divide polynomials by monomials and binomials using both long and synthetic division. Before we get into long and synthetic division, those sound like scary terms, but they're really not. It's real easy stuff. I want to just talk about some basic things that we can do when we have division or a fraction. And really, that's all division is, or that's all a fraction is just division. So what I want to point out here is you'll notice that we have this big long polynomial over what we call a monomial. Well, if you think about it, all these things are being added and subtracted together, and they have this common denominator here, this common denominator. So what we can do is we can actually separate them all and write those as common denominators. So let's go ahead and do that. So what I'm going to do is I'm going to say, hey, this is 18x to the fourth over 6x minus 3x squared over 6x plus 6x over 6x minus 4 over 6x. Notice what I did is I separated out all the terms and I put them all over 6x, because really that's what this is. This is just all these things over 6x, so I separate it all out. Now what we can do is we can go through and simplify each of these individually. And I want to talk about this first one. What does this really mean here? What I really have is I have an 18, and then x to the fourth is really like saying x times x times x times x over 6 and then just 1x. Well, we can easily see that 6 goes into both 18 and 6, and we get a 3 and then a 1. And when you have x to the fourth, that's really like saying 4 x's times to each other. Well, we can just cancel out one of those x's. So let's get rid of just one of these, and we're left with 3 x's. So really this reduces down to, or simplifies down to 3. We don't really need the 1 on the bottom. X, and 3x's times each other is 3x cubed. Now, that's a long way of doing it, and I just did that to kind of explain how we're going to get our reduction here. But let's take a look here. We got 18 divided by 6, that's 3. And x to the fourth and x to the 1 is really what this is. And so we can really just say, well, I have 4 x's on top, and I'm dividing out one of them, or I'm taking away one of them. So you can actually just subtract exponents here, and that's pretty fancy. So we could just say x to the 4 minus 1 is 3, so this is x cubed. That's supposed to be an x. And this whole explanation over here, this explains why that works, but I just want to show you could just kind of subtract exponents, and this is why. Okay, next we got minus, well, a 3 and a 6. We could take a 3 out of both of those and you'd have a 1 and a 2, so I'm going to say 1/2. And remember, I have an x squared and an x to the, you could think of this as an x to the 1. So 2 minus 1 is just 1x, so we can call this just x plus 6x divided by 6x. Well, that's just, anything divided by itself is just 1. And then lastly, over here, we could take a 2 out of both of those. So I could take a 2 out of both of those, and I'd have a 2 over 3x. So I'm just going to write, oops, almost wrote plus, minus 2 over 3x. And now I've simplified down this expression. And that's perfect. That's exactly what I want to be able to do. So on the next one, I want you to try it on your own. Go ahead and see if you could separate it out and simplify them all down, and then you're going to want to check back with the video to see if you did it correctly. Okay, so when I separate it all out, I got what I have written here in black, and then I just started playing with what I could cancel out. Again, I have x to the 6, and this is x squared. So I can just subtract 6 minus 2 is 4, so that gives me x to the fourth. X to the third over x squared, that means I'm going to take away 2 x's, leaving me with just 1x. Here I can take away 1x on top, right? I have 1x on top and 2 on bottom, so that means if I was to cancel out one of those, I'd still have 1 on the bottom. So this is 2 over x, and then this is just simply 1 over x squared. Doesn't really simplify much more than that. Okay. All right, let's go back in time. let's go back to 4th grade when we learned about long division, okay? And let's just do this problem right here. It's already worked out for us, but let's just talk about it. We have 128 divided by 5. So that's really like the high school way of writing 128 divided by 5. But let's just think back in terms of like 4th grade. Well, at first I would check. I'd say, does 5 go into 1? And it doesn't, right? So then I would go to the next digit, and I say, okay, does 5 go into 12? And it does. And we know that it goes in there at least 2 times. So we do 2 times 5. Oh, they do this whole subtract 0 because it doesn't go into 1 at all. But that's okay. So we go to the 12. So 2 times 5 is 10. All right, so I put a little 10 here. And then remember, I do 12 minus that 10, and I get a 2. Then I bring down the 8, and I got 28. So I ask myself, okay, does 5 go into 28? And it does. It goes in there 5 times. So I do 5 times 5 is 25. Then I subtract, and I have a 3, and we would say my answer is 25, remainder 3. Well, what that means, remainder 3 actually means 25 and 3 over whatever you were dividing by. So 25 and 3/5. So 128 divided by 5 is actually 25 and 3/5. And you could do it in your calculator. You're going to get the exact same thing. It'll probably give you a decimal. It'll be 25.6. But this works. So I just take my remainder, I put it over whatever I was dividing by. Well, it turns out we can actually use the exact same process with polynomials. So let's go ahead and do it. One of the main things we have to check for, though, before we do it, is we have to check and make sure that all of the powers are there. So let me explain what I mean by that. Notice that this one starts with a 2, and then this power, it's not written, but it really is like a little 1, right? And then this power is also not written, but this should be like an x to the 0. And anything to the 0 power is 1, and that's why it's not there. So it should go down in order, 2, 1, 0. All right, good. What we don't want is like a 3, 1, 0, because then we'd be skipping a 2, and so we'd have to account for that. Basically, we account for that by just putting in a 0 as a placeholder, but this one works well. It goes 2, 1, 0. Same thing over here. It's going to go 2. There's really an imaginary 1 there, and there's nothing here, so that's like a 0. 2, 1, 0. So we're going just fine. But we have to make sure that everything's there. Otherwise, we're going to have to add a placeholder in here to account for a missing spot. But we're good. So we're ready to just go ahead and do long division. And the whole time, we're just going to be thinking about all the same steps. Because there's no new steps here. It's all the same steps you learned in 4th grade. It's just now we're doing it with polynomials. So let's take a look here. The first thing we're going to ask, and here with long division, we really only look at the first term. You know, there's 2 terms here, but we really just look at the first term to start off. And I ask us, what do I need to get x to go into x squared? Well, I just need another x, right? X times x is x squared. So what I do is I'm going to go right here, and we're just going to write an x. So now I think, okay, well, what is x times x? We just said that. It's x squared. But I don't have just an x there. I have x minus 4. So what's x times negative 4? Well, it's negative 4x. So I'm going to put negative 4x. Okay, remember, now what we did, we're kind of like on this step right here. We subtracted. But we didn't just subtract the 1 or just the 0, right? We subtracted the whole thing, the 10. So what we have to do here is we have to, I'll do it in another color, so you can see it, is we have to subtract this whole thing. Well, that's pretty easy because x squared minus x squared, well, that's 0. And so that's easy. But this is where it gets a little tricky, right? So I have a negative 3x minus a negative 4x. And this might be hard for you to see in this way, but really what you're thinking about here, and I'll write it over here on the side, what we're really saying is we're saying negative 3x minus negative 4x. Well, remember when you have a double negative, you add. So really, this is like saying negative 3x, double negative, plus 4x. Well, negative 3x plus positive 4x is just positive x. So I'm just going to write plus x. Okay. Really, it seems confusing, but it's really just the same thing that we were doing here. It's just now we have x's and coefficients and stuff like that involved. No big deal. I want you to notice what we do next now. Look, after they subtracted 12 minus 10, you had a 2, they brought down the 8. So we're going to bring down the 1. So let's go ahead and do that. and it's a plus 1. And I really can just ignore this 0 out here. It doesn't really matter because it's just 0. And again, I just look at the first term. What times x equals x? Well, that's easy. It's just 1. So right over here, I'm going to put plus 1. So now 1 times x is x. So I'm going to write an x down here. And in the same way, 1 times negative 4 is negative 4. So I'm going to write a negative 4 here. Remember, though, I'm subtracting this whole thing. So when I go through this, I get an x minus an x. Okay, that's easy. That's just 0. I put a 0 here. I don't even really need to put the 0 there. But the next part, that's again where it gets a little tricky. I have a 1 minus a negative. Minus a negative. Minus a negative means positive. So this is really like saying 1 and positive 4, which is 5. So I'm going to write plus 5. Okay, and now I'm pretty much done. There's no way I can get an x to go into a 5. There's no x's left. And so what I can do is I just go up to the top and I write remainder 5. And what does that really mean, remainder 5? Well, remember, we said up here, the remainder is just what you put above whatever you divided by. Well, here we divided by x minus 4. So I can say that the answer here is x plus 1 plus 5 over whatever we divided by, which is x minus 4. And now I just divided a polynomial. I divided x squared minus 3x plus 1 by x minus 4. And it really wasn't that bad. There was nothing new that I did here. I just kind of had to think of it in a new way. All right, so practice number 2. I kind of already have it set up for you. You're going to divide using long division. I'm going to start you off and then you're going to finish it. Remember, what you're doing here is you're asking, your first question is, what goes into 2x squared? Or what times x goes into 2x squared? And the obvious answer there is 2x. So you're going to start with a 2x. I'm going to let you try and figure out the rest from there. Hopefully you can get it. Check back when you're done to see if you did it correctly. Okay, so if you did this right, you should have ended up with 2x minus 3 remainder 0. Whenever you have a remainder 0, that's kind of interesting because that means that you found something that goes in there perfectly. That means that x minus 8 goes into this whole expression perfectly. And 2x minus 3 must go in there perfectly. In fact, these two things are factors. So what this really means, and this gets pretty interesting because it's getting us into the next chapter. What this really means then is that 2x minus 3 times what you divided by, x minus 8, that should actually equal, and I'm running out of space, but that should equal exactly what we had inside the dividing symbol. And we can check that. We can actually do that. We can do box method. We did this last video. We could say, okay, what is 2x minus 3 times x minus 8? I'm going to zoom in here so it's a little bit easier. But let's just kind of play with this. Well, 2x times x, that's 2x squared. X times negative 3, that's negative 3x. 2x times negative 8, that's negative 16x. And negative 8 times negative 3, negative times negative makes a positive 24. Well, these two are like terms, so we can add these together, and we end up with 2x squared. Negative 3 and negative 16 makes negative 19x plus 24. Does that match? Let's zoom out and see here. Yeah, that's exactly the same, right? This is the exact same thing as that. So when you get something that's a remainder 0, that means you found the factors. And we'll talk a lot about that in the next chapter. So kind of neat. They'll multiply back and you'll get exactly what you started with. In the same way that if you had 8 times 2, or I'm sorry, 8 divided by 2, you'd get 4, right? Well, that means that 2 times 4 equals 8. The same thing's true with polynomials. All right, let's go to the next page. Okay, now we're going to go into synthetic division, and this is kind of interesting. Basically, we're going to do the exact same problems we did before. Same thing applies. We have to make sure that our exponents are all there. But these are the same two problems on the previous page. So we're going to get the same answers. It's just a little bit quick. I'm just showing you how we can do the same problems a different way. But yeah, there's a 2, there's a 1, and there's a 0. There's a 2 as the exponent. There's a little imaginary 1 as an exponent. And there's no x here, therefore the exponent of the x is 0. So 2, 1, 0 counts down perfectly. 3, 2, 1, 0. Yeah, so these are all going to work just fine. No problems here. We don't have to worry about placeholders. If you remind me, I could show you about placeholders in class. But let's just go ahead and do synthetic. Let me show you how we set it up. The first thing we look at is whatever we're dividing by. And we ask this question, what would I plug in here to get this to equal 0? Okay? Remember, how would I get my divisor to equal 0? That's what I'm asking. Well, in this situation, if you plugged in a 4, you'd get 0. 4 minus 4 is 0. So I'm going to put a 4, and then I just do a little square like this, or a little part of a square. And then, it looks kind of crazy, but you just draw a line across, and you just write all your coefficients. So what are all your coefficients? If you look here, the very first thing is x squared, and that doesn't seem to have a coefficient. That's because it's an imaginary 1. So I just write a 1. The next coefficient is -3, and the next one is 1. Once you get to the last term, you put a box down below. And it's pretty straightforward. You are just going to just follow these basic steps, and you'll see it's pretty easy. I'm going to work this out in blue so you can kind of see my process. You always bring the first term down. Just bring it down. So that's just a 1. Then from here, you do whatever is in this top corner, you multiply it by this thing. So 4 times 1 is 4. We're going to put a 4 there now. Okay, and then we just add. -3 and 4 makes +1. So I'm going to put another 1 here. All right. Okay, again, repeat the process. 4 times this one now is, again, +4. So I put a 4 here. And again, I just add. 1 plus 4 is 5. This box here is your remainder. Now, this is where it gets a little, I don't know, kids get hung up on this, but I think it's actually really easy. In the same way that we made sure our exponents went down 2, 1, 0, and we ended at 0, we're going to do the same thing here. So this is like x to the 0. And then we just count up, but we go backwards. So x to the 0, x to the 1, and there is no x squared, so we don't have to worry about it. And if there's no negative sign, that means we're adding. And so we could just kind of clean this up a little bit. What is this really? This is like saying this is like saying 1x to the 1. Well, we don't really have to write 1x to the 1. We could just write x plus, remember, x to the 0. X to the 0 just means that, you don't even have to put an x there. It's just nothing. It's just 1. So 1 times 1 is 1. And then we said we have a remainder 5, so that means we have 5 over whatever we were asked to divide by. And remember, we were asked to divide by x minus 4. So x minus 4. If you take a look on the previous page, it's the exact same answer that we got from doing long division. That's because it's really the same process. It's just kind of a little shortcut. So you kind of want to know how to do both of these because each way can come in handy in different scenarios. But I think synthetic division is really nice. The problem synthetic division is it gets a lot more complicated when you have a number in front of the x here other than 1. So if you have like a 2x here or a 3x here, then it starts to get a little bit more complicated. But it's really great for these simple division problems. So I'm going to write up what this next one should look like, and then I'm going to let you do all the work. So we know that we need to first figure out what would make this thing equal 0. That would be 8. 8 minus 8 is 0. It's pretty easy. It's just the opposite. So we put an 8. That goes in the top left corner. Draw my line. Put all my coefficients. It's 2. It's -19. It's 24. The last one, and the last one goes to box for the remainder. All right, I want you to just go ahead and give this a try. Remember, you just bring the first one down, then you just multiply, add, multiply, add. Pretty easy. Give it a shot and then check back when you're ready to see if you did it correctly. You could even check on the previous page to see if you did it correctly because you should get the same thing as practice 2. Okay, yeah, so I brought down the 2. 8 times 2 is 16. Negative 19 and positive 16 makes negative 3. 8 times negative 3 is negative 24. Add those together, you get 0. You got a remainder of 0. So our answer here is 2x minus 3. Let me just go over this again real quick. Remember, you start with 0 as the power, and you just count up, but you go backwards. X to the 0 is really just 1, so you don't have to worry about that one. And x to the 1 is really just x. So this is just 2x minus 3. That's it. I'm going to give you guys one more to try on your own. This one I'm going to let you totally try on your own so you can set it up and everything. The only thing that I'm going to help you with here is, remember, we want to know what would you plug in there to get a 0. And so your very first number is going to be negative 1. See if you can't set it all up the rest on your own and solve the rest on your own and check back to see if you did it correctly. Okay, let's go over it real quick. The coefficients were 1, 4, 1, negative 6. So bring down the 1. Negative 1 times 1 is negative 1. 4 and negative 1 make 3. Negative 1 times 3 is negative 3. 1 and negative 3 is negative 2. 1 and negative 1 times negative 2 is positive 2. And negative 6 and positive 2 makes negative 4. So then I just fill in the spots, x0, x1, x2, and then I could kind of simplify it. That's an x squared, that's a 3x, that's just a negative 2, and remember, whatever my remainder is, I put it above whatever I was dividing by, so negative 4 over x plus 1. And that is it. All right, so what I'd like for you guys to do is describe the difference between using long and synthetic division. Use your own words to just kind of describe what you think is the difference. I expect, 1 or 2 sentences. And then explain which method you prefer and why. So you should give me about 3 sentences there of explanation of what the difference is and why you like one over the other. Okay, see you guys in the next video.